Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
Okay, so now that we've started our Sentinel journey, um, let's proceed with our second option for downloading or accessing and downloading Sentinel images. But before we get to the second option, remember that I indicated in the previous video tutorial that it's indeed possible if you go the, to create or to upload a file for your region of interest using that little option there. But remember, you have to be subscribed if you have to be logged in. Now, you can try this, but as I said, it makes the thing very, very slow. Especially if you have a large region of interest. If you have a small region of interest, you can upload your region of interest. So you just click on that one and it will tell you what to do. Okay, so you just drag or upload it there. But if you have a sizable region of interest, such as what I have, then uploading your region of interest as a file makes it very, very difficult. Things just becomes very, very slow. So I prefer to draw my own region of interest, and then I prefer to actually clip it in QGIS. For me, that just makes it's faster and easier, but doesn't mean I'm correct. You can choose any other way. Then also, when you download, remember, you go to download and you do analytical. Um, Select the 32-bit float. That's advisable, and then also select the high resolution. Okay, so please remember to select those two options. That gives you the best possible images. And just to indicate that to you, what I've done, if I go to QGIS, I have downloaded the first set here, the first couple of images, these ones here. They are the high resolution float. If I go to properties, I go to saw information, you'll see it's a float, 32-bit float. Okay, so it's a bit 32 float and it's high resolution. Okay, if I go to the second bunch, these ones here, okay, and this one included, sorry, that one there. If I right click, I go to properties. Okay, you'll see it's just a bit 16 and it's medium resolution. Okay, so that's the difference between the two. As I said, if you go to the download option, you get your download option. This is where you click whether it's 32-bit or 16-bit. Okay, I would suggest go for 32-bit and go for high resolution. Okay, and you'll see the difference. Again, if I go to Earth to QGIS, um, that is band 12 in the 16-bit medium resolution, and that is band 12 in the float 32-bit high resolution. And you can clearly see the difference. Now let's go to, let's say, to another one. So that's band 4 in the 16-bit medium resolution, and that is the image for band 4 for the 32-bit float high resolution image. You can see the difference in terms of the resolution and the clarity of the picture. Okay, you can definitely see that. So that's why it's important to play around with this to see what gives you the best options. Okay, but anyway, so that basically concludes our exploration of Sentinel images for option 1. Okay, downloading our Sentinel image, option 1, which is working through the Sentinel Hub. But I said, remember, You work through the EO browser and you have to be registered. Okay, you have to be registered. So that's option one. And obviously, as I said, once it's downloaded, you basically just bring the files into Earth Engine. Now, as I said, it still has to be clipped. Okay, it still has to be clipped because I have not used this file in the Sentinel hub. As I said, it's just too cumbersome. It just lags the whole thing. It just becomes a pain in the butt. Rather just throw it and do your clipping in Earth Engine. In QGIS, sorry, my apologies. In Earth Engine, where you simply just go to raster, you go to extraction, you go to clip by mask layer, and you use the batch process. Okay, and you'll clip it, and it will look something to this effect. It will be clipped. Okay, anyway, so that's option one. Option two, we go to our trusted Earth Engine, our beloved Earth Engine. Okay, so let's work with it in Earth Engine. So I'm gonna go to datasets first. Okay, we're gonna go to our Sentinel dataset. We already determined that we're using Sentinel 2 and specifically surface reflected, the one that's atmospherically corrected. You'll see if you go to Sentinel Hub, if you go to the Sentinel 2, if you uh, open this, come on, open it, you'll say it's atmospherically corrected. Okay, what does it mean? It says this high quality data with effects of the light being reflected of the surface of Earth is excluded. Okay, so it takes away that distortion of the atmospheric reflectance. Okay, so we know now that we're gonna, if we work in Sentinel-2, that's at atmospheric corrective for surface reflectance. Okay, so we click on that one there. And there's the date that it started, where it comes from, the ID number or ID path for the images, and it's the harmonized one. There's all the you can go to the description. There's all the bands. Remember, it's scaled. We have to do the scaling, or you can ignore it. That's up to you. But just remember that if you work with the raw images, for example, the images in Sentinel Hub, those are unscaled images. So for example, if I click here, any of them, let's click that one there, and I click on here, and I click any place there. Um, why is it giving me, it's supposed to give me not band 1. Why is it giving me, where's band 1? That's supposed to give me band 1. Let's quickly go there, highlight it there, that band 12. It's giving me a 0.459, which is not what I'm looking for. There we go. You see there, it's 18,389. Okay, so that's the actual value, but in Earth Engine, um, within Earth Engine, it is scaled by, where is it now? Three zeros. Okay, so you have to multiply it by 1,000. Okay, you have to multiply it by 1,000. So let's go back here, go there. If I take this one there, if I multiply it by 1,000, I get to 5,442, which is on the same scale as this one here. So it's in thousands. Anyway, so please remember to take note that there's a scaling factor. The scaling factor is 0.01. Okay, so that's important. And then obviously the spatial resolutions, pixel sizes. So that's important to note. Again, as always, here at the bottom is our trusted script or our code to get started with the Sentinel images. Okay, there's our function for cloud removal. That's the function for cloud removal. And you copy and paste it. There's our code or script to get going with the images itself. In this case, it's the image collection because there's multiple images. That's the unique identifier of the Sentinel. That's the range. And then we filter for the clouds and we map it without the clouds. There's our visualization parameters. You'll see the minimum and max is 0.0 and 0.3 because these ones are in decimal numbers because they are unscaled. So this code, don't scale it back to. Remember, we did it in times in the environmental ones where we put a scaling factor where we scaled it back. Here it's unscaled. There's our map center, and that is to add the layer using the mean reducer. Okay, so basically you can just copy and paste it. Okay, so we've already, so we just copy and paste it. And then we're gonna paste it into a script, and then we're just gonna delete all the comments. So for example, these ones are comments, these in green. In pink color, reddish pink color, they are green, so we just delete it. And we also delete our map center because we already got a map center. Okay, so there's the code for the clouds, which is that one. So for the code as it is in Earth Engine, excluding the comments. And then there's it. I've just changed the name. Remember this, just change the name. Remember here it is called dataset. The variable name, I just called it Sentinel 2024, and I've clipped it. Okay, so here I'm clipping it for my region of interest using my clip to column tool. That is our standard clip to column tool. Okay, and it is for my region of interest, and I've already brought in my region of interest as a variable. It's my region of interest shape file, so I bring it in. Remember, normal assets. There it sits. There it is. I click on this button there. And then I just click on it and I change the name there. Okay, so there's my region of interest. And I create a clipping tool around for my region of interest. Okay, I add my region of interest and I map center. Those are all standard things that we've done now numerous times on our video tutorial. So that should be standard practice. As I said, I always start with those things. There's my cloud cover, okay, my cloud cover to compensate for cloud cover. And now I'm actually generating an image from my image collection. Now this is again quite tricky because if you go to the Sentinel, we know, if I just go back to the months, February, okay, so we know, search. Did I put it on? Yeah, we know there's an image, a Sentinel image that fits our criteria, that fits our cloud on the 19th of February. We know that there's it, the 19th of February. We know that one exists. The 19th of February, and it has an ID. If I go back there, if I go to the 19th, you'll see it will have an identification number. If I go to the 19th, let me just quickly go there. 19th, you'll see if I click on this button here. See, there's it, 34HBC. If I click there, there's its identification number, 34HBJ. That's its unique identifier. And it gives you the date and all these sort of things. So I'm interested in downloading that image in Earth Engine. But unfortunately, the Earth Engine doesn't, you can't, if I, for example, do that. So I know there's the one on the 19th of February. I know that there's image. I've seen that image. Okay, so that time period now is exactly what this period is. You see there's 19 of the 24th, 2022, 8:45, 0, etc. So I want to download that one. If I click run, Um, it says that they can't find that image. They can't find that image. So unfortunately, there seems to be some issues with the timing between Sentinel Hub itself, the image date in Sentinel Hub, and the image date in Earth Engine. So unfortunately, it's going to be a bit tricky. So I've just made it. I've extended my dates a bit so that it covers a month, but unfortunately there could be now more than one image, and therefore I have to use a reducer, and we already said we're using the medium reducer. So unfortunately, The image that we're going to generate for Google Earth Engine won't be the same as the image that we generated through Sentinel Hub. Because the Sentinel Hub will be a singular image. It will be an image at a point in time, whereas my image in Google in Earth Engine most probably will be a reduced image consisting of one or two or more images. So the images won't be 100% compatible. However, there shouldn't be too much differences. I mean, if the one says there's water and the other one says there's a building, then obviously there's some issues there. So there's not going to be too many issues between the ones. Well, we're going to have a look at it. That's still to do. But anyway, just take note of it. It's very difficult to get to exactly the same. There seem to be some issues. Okay, but nonetheless, I clip it for my region of interest. I have my filter dates, which is plus minus around this date of the image that I have in Sentinel Hub. Okay, I generate, and I'm not scaling it. I'm just using it as is. We actually should scale it. So in the next video, I will put in the scaling factor so that the scalings are exactly the same. Okay, I'm using a medium reducer. We've already showed it in many of the previous videos, tutorials, that using the median is the better option. But remember, you can use the mean, you can use the sum, you can use a minimum number, maximum, that's up to you. Then we have our visualization parameters, and then we actually map it to our um, um, layer. Okay, so let's quickly have a look at it. So I'm gonna go and unhide all these. We'll get to all these ones. I'm just gonna, oops, without clicking do that. Okay, it does take a bit of time, as you know. This is not the biggest region of interest, but nonetheless, it's still a sizable region of interest. And there is my Sentinel-2 image. Now, this Sentinel-2 image is presented in true color, meaning band 4, band 3, band 2. Okay, so band 4, which is band 4? Band 4, if I go to my bands, band 4 is red color. Okay. Band 3 is the green color, band blue is the 2 color. So it's red, green, and blue. Red, green, and blue. And it's a minimum maximum is decimal points because we have not scaled it. Now, obviously, if we're going to scale it, we have to change these minimum and maximum numbers. So they're there, and then obviously I'm going to export it. I'm going to export it using my export function. I'm going to export what? I'm going to export the image, and I'm going to export it to my drive. Which drive? My Google Drive. My Google Drive. And there it sits. Okay, so I'm going to go Google Drive. I'm going to export this image here, which is a medium Sentinel image for this period. Now, if there's only one image in that period, that will be that. There won't be a medium. If there's 2 or 3 or more images in that specific period, then it will take the medium image. Okay, so it will just add them and then generate a medium value for each pixel, and that becomes that, and it's cloud-based. So I export that. So when I run, I get my image. It looks like that, and then it opens up in the task as an unsubmitted task. I click run. Once I press run, I just now wait until it is submitted. It gives me in blue. Once it's in blue, you can go to your Google folder, and there it sits. And then from there, you basically just download it. Okay, and you download it into your project folder. Once it's in your project folder, okay, once it's in your project folder, you can bring it into, let me just go down, make it, unselect these ones. Once it's in your project folder, you can bring it into QGIS, and there it sits in QGIS. It's trying to open it. It's, as I said, it is quite sizable, so it does take a bit of time. So it sits in QGIS. Okay, so there it sits. And again, how do I bring it in? I go. So it's saved in my project folder. So let's quickly go there. So I've saved it in my project folder. There it sits. There it is. Sentinel 2024. Sentinel 2024. Let's go to Google Earth Engine. You'll see it's Sentinel 2024. In Earth Engine, it's Sentinel 2024. So once it's um, uh, in the export option in the task window, you click run and you run it. This case, it took 6 minutes to run. It will then save it into that folder. Remember, I created that folder, the project folder. Okay, so there's my scaling factor. Again, you can play around with this, but in general, we use 30-bit, but you can play around with this. Then we put it in our project folder. There's my, you see, project folder. It's there. You right click there and you download it. You save it into your project folder. And from your project folder, you go to layer, add layer. What are you going to add? You're going to add a raster layer. I'm going to go to my project folder and there it sits. You'll see it's quite sizable. And then you just press open. And once you've pressed open, you just add. Now I've already added it, so I'm not going to do that, and there it sits. And there's your image. Now, just bear in mind, I've reshaped the images so that it's 432, but if we want to quickly compare it to our Earth Engine um, image, as it's displayed in Earth Engine, there's our Earth Engine image. Okay, there it sits. Okay, so and that remember this is now also 4321. Okay, so this is also 4321. So this image as it's displayed there and this image as it's displayed in QGIS is exactly the same image. There's no difference between the two. If I go in, I zoom a little bit, I can zoom in, I can see there's my urban areas there. There's sandy patches here, there's some vegetation, there's a river, there's the mountains, etc., etc. And if I go back into Earth Engine, you can see again there's my urban areas there. Okay, let's just wait a bit. It does take a bit of time sometimes. Anyway, um, okay, so there it is. It's indicating my urban areas there. There's my urban areas there. There's some sandy patches there. These are grasslands or vegetation. There's my mountain areas, etc., etc. So you can see the two images, one in Earth Engine and the one in Google Earth, sorry, Earth Engine and QGIS. But the two are fundamentally the same image. Now, if we right click here and we go properties, you'll see that if we go to symbology, you see that we have the red value in the red band, the green value in the green band, and the blue value in the blue band. Now, if we swap it, we get what we call it through the false color. If we put blue, if we put red, we put red in the blue band, green band stays green, and then in the red band, we put blue. So it's 2, 3, 4, not 4, 3, 2. So we just swap the red band because the red band goes into the blue band position and the blue band goes in the red band position. If I press OK, you'll see there that they're swapped around. And then I was just waiting for how that looks. Now, in the meantime, while that is trying, let's quickly go in Google Earth Engine and do the same there. You'll see that. Remember, we press on that little nut there, and that gives us our band combination. So again, we just swap it here to 2, which will be band. The blue band becomes in the red. The green band stays in the green, and the red goes into the blue band. And we just apply. Let's see what that looks like. So that's what so that becomes this. And in QGIS, it looks like that. So that's the difference between the two. Exactly the same, but you see here's the range 0 to 0.3, and that is the difference now between the colors because here the range are very, very different. So if we make the range 0 to 0, 0.3 and we make the range there 0 and 0,3, and we make the range there 0 and 0,3. Let's have a look and see what that looks now. It's going to take a bit of time now for it to generalize. So let's go, in the meantime, let's go back to Earth Engine. You can see we've swapped the band, so it's 2, 3, 4, and the range is 0 to 0.03. And the rest we left exactly the same, and it gives you this very bluish picture. And you can see that it's if we go into QGIS, it's exactly the same. Okay, so it gives us some confidence that the process works. Okay, you can see that it's exactly the same. Well, I wouldn't say exactly the same, but it looks the same. It mirrors the same. Okay, now let's quickly have a look and see if we go to a specific position. And again, that's very difficult, but I want to go and see if the values, the band values are the same. Okay, so let's quickly identify a place. So let's look at um, this space here. Let's go and have a look and see if we can isolate it in here as well. So that's that space there. Okay, so let's have a look and see. It's that space there. Um, if I go into like satellite, then I think it's a field there. Yeah, it's an open field. If I go into Earth Engine, that's that open field. So if I use my inspector, if I click on that, it will give me the values of the bands, the spectral signature of that place. You'll see there's band 1, got a value of 0.1. You see, it's actually should be multiplied by 1,000, because remember, it's not scaled. So just remember that. If I go here, make sure I've got that selected. I click on that value. Now it's plus minus, because it's not exactly the same. And you'll see band 1 is 0.113, and here it's value 0.107. Very similar. Let's have a look at band 9. Band 9 is 0.378. Let's go here and look at band 9. 30. See, very similar. So, the image that we have now in Earth QGIS is exactly the same as the image in Earth Engine. Okay, whether it is the values, whether it's the color schemes, etc., etc. Okay, so they're exactly the same. But obviously we've only compared it with the image in Earth Engine. We haven't looked at the image as we derived it from the Sentinel hub. Okay, that's something that we're going to do in a later video. Okay, but for this particular video tutorial, we've now accessed and downloaded a Sentinel image as we generated it in Earth Engine, and then we have moved it to, let's make it, and then we have moved it to QGIS as well. And with QGIS, we can replicate that image. You can see the band values are still the same, the color schemes are exactly the same, no difference. So we can either now work with this image within Earth Engine. Okay, so we continue working with the image in Earth Engine, or we can continue working with the image in QGIS. So we will now in QGIS have a Sentinel image for my region of interest for my specific period. And we have a similar image but derived from Sentinel. And we'll have a look at those two to see how they differ or how they are similar. Okay, well, yeah, so that is option 2, working with our trusted Earth Engine, working with our trusted Earth Engine. But just to indicate to you that when we move that Earth picture to QGIS, we can do exactly the same. Okay, well, thank you. Thanks for joining me for this video tutorial. We're on our way on our journey with Sentinel, and thanks for joining me. Thanks for staying tuned. Please remember to like, subscribe, hit the notification bell, share the video. I can really do with your support. And I'll see you on the next one. I'll see you on the other side.